us about why do online countering violent extremism strategies not work and the case of digital jihad. So yeah, feel free to start when you're ready.
Okay, thank you. Thank you so much. Let me share the screen.
This is going to be on the topic of operationalizing AI ethics and safety in generative AI. And this is going to be hosted by Siddharth Chatterjee, who is a public policy and governance strategist. So.
Good morning, and thank you for having me over. Very quickly, the topic of my lecture today is on operationalizing safety and ethics and generative AI. A little bit about me and the organization that I represent. I am Siddharth Chatterjee. I'm a part of the public policy and governance team at Holistic AI. At Holistic AI, we provide comprehensive AI governance, risk, and compliance solutions for enterprises across sectors. So from recruitment to healthcare to commerce, across a wide variety of algorithms, recommendation systems, generative AI, so on and so forth, through a proprietary GRC platform. And there's a lot to cover today, but before kind of going into the session, we'll start by setting the context, really kind of probe the question as to why AI safety and ethics need to be operationalized in the first place. Isn't regulation in itself enough? We'll then kind of dive deep into the how of it. How exactly should this be operationalized? Critically looking at two modes of ethics and safety operationalization, model evaluations, and algorithm audits. We'll then kind of look at their different types, critically assess different characteristics, limitations, etc. And finally kind of look at how these interventions really play out in the practical context. How can they be made useful in guiding the responsible development of AI technologies post hoc? Finally, we'll wrap up with some concluding remarks and take some question and answers when time permits. Let's start with the obvious. We're currently in the AI moment. AI development, deployment is seeing massive adoption, deployment across different sectors. There's widespread acceptance, adoption, usage happening from recommendation systems to generative AI models, seamlessly generating code, text, image, audio, video, etc., to as well as a lot of sectoral applications of AI within healthcare, commerce, climate change, human resources, so on and so forth. And while all of this innovation is great and it's really kind of, this very exciting time to be alive, these systems really come with serious risks and harms associated with their deployment. Right from ChatGPT being banned in Italy effectively last year over privacy concerns to its more recent kind of reportage over the New York Times suing the company over copyright infringement, the risk profile that we're looking at for generative AI is quite vast. AI systems that are also kind of faulty, that are not kind of, tested appropriately for sort of robustness and efficacy, also lead to serious reputational, economic, and commercial damage for organizations. With an example from, Google's Bard, the ineffective chatbot, costed the company around 100 million. And a similar example from the financial services world with Knight Capital's trading algorithm, costing it again over 440 million only because of a faulty algorithm. And of course, apart from all of this, the surface level articulation of the harms, there are also systemic harms associated with these models, especially when they reflect stereotypical biases due to improper training data sets that are associated and are along gendered, biased, race sort of lines. And just take this, sexist AI tool developed by Amazon that was used to filter job applicants and was biased against women. This, of course, had to be put down eventually. But what the point I'm trying to make is that these can have serious implications and ramifications if used in pervasive technologies like biometric systems, where they might discriminate against vulnerable groups that are already not represented in, kind of reportage as well as in training data, thereby sort of exacerbating problems for them. And as a result, governments worldwide have really accelerated and ramped up their efforts to understand and regulate these systems. Leading this charge, of course, is the European Union, which last week published the latest iteration and the final iteration of the EU AI Act, which seeks to be this global first risk-based regulation that horizontally governs AI systems across capabilities, across use cases, across contexts, etc. We also had the Biden administration in the US issue the executive order on AI back in late November 2023. which again was pretty comprehensive in terms of its coverage, in terms of how it was enforcing against different AI harms, in terms of its coverage of different sorts of risks emanating from AI systems, so on and so forth. And if you go east, you have countries like China that, publish and issue AI regulations on different sorts of, technologies like generative AI, like large language models, like recommendation systems, almost every quarter. So regulatory momentum on AI is really kind of growing, and this map on the screen really kind of, very eloquently shows that. But it's also very important, as we're kind of talking about regulations, to really probe the very question as to if regulation in itself is enough. It is not, very clearly, because of three reasons. The first one being that they are unable to pace with the ever dynamic AI ecosystem. For example, take the EU AI Act, which is, well, reportedly the world's most comprehensive legislation on the AI, on artificial intelligence. It did not have a single dedicated provision for generative models like ChatGPT, up until the point that ChatGPT actually sort of exploded onto the scene. Secondly, there are very real dangers that are associated with regulation being overprescriptive, as it can, stifle innovation. And thirdly, a practical implication of regulations is that they increase the cost of compliance. And this increase in the cost of compliance can make the already uneven playing field a lot more unequal, especially for innovators, startups, and SMEs looking to develop innovative breakthrough, applications in AI. And how do we solve this? We solve this by baking in socio-technical interventions right from the outset that measure, monitor, and mitigate a model's risks throughout its life cycle. We do this by leveraging two sorts of interventions. Of course, there are many, but I'll cover two today. Model evaluations, colloquially called evals, and audits. While evals help sort of gauge the model efficacy, the rate of model efficacy and mitigate risk during a model's life cycle, audits are a powerful way of independently stress testing, interrogating models against different sorts of risks. Audits can also help assure models and can also act as very strong signals of regulatory compliance. And of course, these are made potent, and these can be made potent through institutionalization. And therefore, these tools should be grounded in ethical considerations, which I'll talk about in a second, codified through regulations, and implemented through standards. But before we sort of go deep into these tools, it's really important that we develop a basic understanding of what really is the applied ethics in this context. While there are hundreds of typologies, formats describing how ethics should look like in the realm of AI, I find it very useful to look at 5 key pillars that help articulate practical approaches towards AI safety and ethics. These are, number one, efficacy, or sort of ensuring whether baseline levels or minimal levels of performance, safety, corrigibility, privacy, etc., are maintained throughout a model's life cycle. You then have robustness, or essentially ensuring that an AI system is not subjected or is not susceptible to external malicious attacks, like cybersecurity attacks, for example. You then have privacy, which is ensuring that data governance aspects are preserved throughout the algorithmic process and personal information is not leaked inadvertently. You also have explainability, which is kind of becoming very popular in regulatory discourse now, which essentially means ensuring that a model's outputs are clearly interpretable, communicable, and the processes that determine an algorithmic outcome are also understandable and accessible as well. And finally, you have something, a very core tenet of AI ethics, which is bias or fairness, which really involves investigating whether an AI system treats individuals fairly, or whether a system performs differently for different groups based on protected characteristics like gender, sex, race, language, economic stratification, so on and so forth. And with this sort of pillar-based approach clear, we move to our first tool, which is ethics and safety evaluations. And I'm going to use a definition from academic literature adapted from Weidinger et al. 2023 here, where they define ethics and safety evals as a set of socio-technical tools that can help investigate, detect, monitor, and determine the efficacy of an AI system's capabilities. Colloquially and broadly speaking, they're really examinations for models that are deployed throughout the model sort of development lifecycle. And this can be deployed in a variety of ways, evaluating across performance levels. So trying to understand how effectively a model understands a sequence of words fed into it as prompts. How are its mathematical capabilities? What is its reading comprehension level, etc. Model modalities. How does a model perform with respect to text, audio, video, code-based capabilities? Model harms. How can harms like misinformation, disinformation, child safety, nudity, regulated goods, privacy, representational biases, allocational biases, etc., be solved for? And also dangerous capabilities, which is kind of more at the existential spectrum of the discourse, which is how can evaluations be leveraged to prevent existential risks like a model replicating autonomously, creating biohazards, cybersecurity attacks, etc. And to kind of, center our discussion on ethics and safety evaluations, we look at two particular modes of doing this. The first one being benchmarking, followed by adversarial testing. But before that, it is very important to ground these evaluations in some sort of context. Broadly speaking, evaluations gauge harms for models across three layers, concentric circles, as seen on the slide over here. The first one being the innermost layer, the capability layer, which is essentially how a particular risk manifests in a model. The human interaction layer, or very simply how humans interact with a model emanating from sort of a generative AI system. And finally, the societal layer, as to how societal constructs, how do societal architectures engage and assimilate with the risks generated by a model. And this kind of happens over a period of time. And I talk about this sort of concentric circle sort of, methodology, morphology, because it helps really guide who is best placed for conducting these evaluations from a regulatory standpoint. For example, capability evals that are concerned with the model alone should be carried out by those who are developing the systems. Think Llama, think ChatGPT, think OpenAI, think Anthropic, etc. Human interaction evals, which measure the extent to which humans interact with the harms emanating from these models, should be largely carried out by those who are actually deploying the model in a particular use case, in a particular context. And finally, over a period of time, civil society and governments may be best placed to assess the systemic risks and the societal impacts that are associated with the model. And with that kind of understanding out of the way, with all of that clear, we come to benchmarking. Benchmarking, very clearly, is really a test as to how a model performs against a series of predefined task questions. Again, like an examination, it's literally a series of questions with answers that are known, and the activity really centers on gauging whether a model's answers sort of match the ones that are already there. And these can be developed internally or taken from public academic databases, which is usually the case. Model evaluations can be used throughout a model's development lifecycle and are used for hill climbing or for iterative improvement. So at every point of the model development lifecycle, you can subject the model to benchmarking to see whether there have been sort of incremental improvements within the model. And if not, what's the reason behind that? This, again, is called hill climbing. As I mentioned before, benchmarking can help, like evaluations, benchmarking can help measure levels of model efficacy. There are aggregate benchmarks like MMLU, Helm that are used to do that. Reading comprehension, there's something called HelloSwag, which helps doing that as well, which is a very cool name. Mathematical capabilities like math, factuality, there's a data set called Factor, as well as model harms, looking at things like representational biases. There's something called BBQ, BOLD, that kind of measures different sorts of representational biases associated with foundation models through kind of the benchmarking intervention. Disinformation, Fever is an example. Toxicity, Google's ToxyGen data set, as well as Perspective APIs are good examples of these. And in addition to hill climbing, benchmarking can also be used to compare the relative efficacy of a model with other sort of competing or state-of-the-art models. And I'll show how that's done in the next slide. For example, in the next slide, you can see this is just an example of how benchmarks can help compare relative efficacy for performance. For example, if you see the first one, Google recently released Gemini, which is a large multimodal model or an LMM. And they use a series of image, general, and reasoning-based benchmarks, such as MMMU, VQA, V2, to compare the model's efficacy with its competitor, which is OpenAI's ChatGPT 4. Similarly, Llama Guard, which was again introduced in December last year, used benchmarks to kind of, really assess the efficacy of it reducing the prevalence of violence and hate, sexual content, criminal planning, guns and illegal weapons, self-harm, regulated substances against, sort of competing models like OpenAI's Mod API, Perspective API, using benchmarking techniques. This is just an example of how benchmarking kind of, plays out. However, benchmarks are, well, not perfect and have limitations. Firstly, there's a perceptible lack of appropriate benchmarks across model harms and modalities. I'll kind of get into this in a couple of slides as well. But very simply, there are the number of benchmarks skew kind of a lot towards NLP capabilities of our language models, of our kind of text-based models. And there really aren't a lot of benchmarks, actually no benchmarks currently for video modalities. Also, benchmarking risks something called memorization, which is when a foundation model is unintentionally trained on open source benchmarks, which is almost akin to cheating in an exam, which can kind of reduce their efficacy. They are also resource intensive. They require significant tooling, annotation, and human evaluation support. And there's also something called the foresight evaluation dissonance, which is very wonderfully explained in this paper by Mary Beth Raw in 2021, where they find a perceptible gap between current benchmarks and future harms, making risk mitigation of, say, unknown knowns and unknown unknowns a very challenging exercise. And finally, over-relying on benchmarks can also lead to something called a capability overhang, where harm types and forms that are not covered by particular benchmarks can be completely ignored. Again, really not able to capture the unknown harms associated with a particular model. And this really kind of signals us to use a bouquet of methods as opposed to a single method, which is benchmarking, to assess and evaluate the ethics and safety of models. Which brings us to a second sort of mode, which is adversarial testing or red teaming, which is this extremely interesting exercise, which involves the model being adversarially prompted, interrogated, or stress tested to intentionally bring out a model's vulnerabilities. This is quite different from benchmarking in the sense that it helps highlight the unknown harms that are associated with a model. Red teaming can and should, very importantly, as opposed to benchmarking, be a participatory exercise, leveraging the pooled collective intelligence of experts from different domains. A red teaming exercise for misinformation, a model harm, for example, can leverage expertise from journalism, sociology, economics, engineering, public health, politics, English, so on and so forth. The more interdisciplinary, the better. And adversarial testing and training can also be automated using language models themselves to develop adversarial prompts. And there's a brilliant paper by Ethan Perez, again at Google DeepMind, on this, or can be used to create a constitutional AI, which has actually been developed by Anthropic, where a model can evaluate its own outputs based on a set of principles or a constitution that it is trained on. And what does red teaming helping with? What is really the explicit purpose of red teaming, apart from kind of, bringing out unknown risks? They can do many things. First, for example, they can, insights from red teaming exercises, for example, can be used to generate model level mitigations, like prompt refusals, system level mitigations, like blocked lists of certain words that are generated through red teaming exercise. Policy development, developing content policy, for different types of harms for deployers of a model as opposed to developers, as well as new evaluation creation. Red teaming is a process that can bring out a number of new unknown harms, unknown risks, and consequently, based on that insight, new evaluations can be created for them. But like benchmarking and like everything else, red teaming also comes with its own set of limitations, which included currently being more of an art than a science, so lack of systematicity, requiring significant resources, and its expertise really being limited to only those who are engaged through the activity. And this really brings us to some of the broader gaps prevalent in ethics and safety evaluations. And I'll quickly look at three graphs to illustrate this. Firstly, there is a lack of evaluations by modality. If you see the first graph in modality over here, you'll see that the number of evaluations for text-based NLP models or language models or your models like ChatGPT, etc., are quite large. Whereas the number starts reducing for image, multimodal, audio, and video. There is almost nothing for audio models, and there is currently no evaluation whatsoever for video models. Secondly, if you look at the second graph, you will see that most evaluations currently are concentrated in the capability layer, which is the innermost layer, which makes sense given that a lot of the innovation and safety work is being done by the developers of these systems. There is still a little bit of coverage at the human interaction layer, which is done by deployers of such systems. But again, evaluations that gauge systemic and social impact are almost minimal in literature as well as in regulatory discourse today. And thirdly, there is also a gap in coverage when it comes to different types of model harms. With a good number of evaluations for harms like representation, toxicity, misinformation, for text, image, and multimodality. But this number again reduces very secularly when it comes to evaluations for malicious use, environmental and ESG related harms related to the energy consumption associated with the compute of the model, so on and so forth. And again, there are absolutely no evaluations for video modalities. And this really signals the need to develop robust validating mechanisms that can scrutinize and monitor models independently. And this brings me to my personal favorite, algorithm audits. Algorithm audits are basically this very simple process of independent system evaluation where an external entity, an independent entity, assesses an AI system's efficiency, efficacy, levels of risks, vulnerabilities, and based on that assessment, offers recommendations to reduce these risks to an acceptable residual level. It is as simple as that. Broadly, there are two types of audits, process out audits or governance audits and outcome or model audits. Process out audits are essentially audits that help assess an AI developer's organizational procedures, accountability structures, oversight mechanisms, governance charters, quality management systems related to the development of an AI system. And then you have model audits, which is more kind of centered around assessing the results generated by an AI system for different sorts of risks like efficacy, robustness, bias, explainability, and privacy. Think about the risks that I kind of mentioned earlier. However, because audits are a novel regulatory tool, it is very important for us to systematize and give some structure to the auditing process. And at Holistic AI, actually, we've developed and pioneered a four-pronged cyclical process to audit algorithms. These are the first one being triage, which this happens during the initial stage of the audit, where the system is documented and is assigned an inherent risk level, which ranges from kind of low level risk, minimal risk, to high risk, which is kind of based on regulations like the EU AI Act, followed by assessment, which is the next phase, where the system is assessed on 5 risk verticals, the ones that I mentioned earlier: efficacy, robustness, privacy, bias, explainability, to give a clear evaluation of the current state of the system. And again, I'm going to go deep on more on this in the next slide. Followed by mitigation, where based on the outcome of the assessment, mitigation sort of measures, actions, recommendations are either actioned or provided to kind of reduce the risk of the system to an acceptable residual level. And these can really be technical, addressing the system itself, or again, can be more governance and process related, addressing sort of issues like system governance, accountability, documentation, things like that. And then we have the final process, which is assurance, which is again this new field that is seeing a lot of coverage now in academic as well as regulatory conversation, which is really a process of declaring a system that a system sort of conforms to kind of predetermined standards, practices, regulations. There's been a lot of standards activity in this space as well, with standards like the ISOs 42001, 42006, 29070, etc., really becoming useful benchmarks or standards to kind of, apply kind of assurance mechanisms against. The EU AI Act as well has a conformity assessment requirement for high-risk systems, which again institutionalizes it and provides an avenue for assurance of AI systems through an audit process. And let's kind of dive deeper into a second and see how assessment and mitigation actually happen. As I mentioned earlier, a variety of socio-technical interventions are used to stress test, interrogate, identify the risk, and then kind of offer operational recommendations. And these can really vary from the different risk profiles that a model probably has. For efficacy, for example, performance standards like ISO 29070 can be used, feedback mechanisms and procedures can be deployed. For things like robustness, which is kind of risk of reducing cybersecurity risk, technical methods like adversarial training, evasion attacks, K-fold CV methods, etc., can be deployed. For fairness, again, there's been a lot of rich literature coming out of the field on AI bias and fairness, and a variety of measures like adversarial debiasing, disparate impact remover, calibrated equality of odds, etc., can be used. Followed by explainability, where you have metrics like Lime and SHAP scores, model cards, surrogate explanations that can be leveraged to kind of make sure that algorithmic processes are not only accessible, they're also communicable and interpretable. And finally, you have privacy, where you can apply a variety of data minimization, perturbation techniques, as well as implement federated learning and differential privacy interventions as well. And again, this is again from literature, actually developed by Mukandar et al. At the Oxford Internet Institute. This actually shows how a large language model can be audited based on a similar approach, which spans a governance audit looking at internal processes, a model audit looking at how the model kind of has been developed, or what is the training data, are there biases, what can be done to address that, followed by an application audit, which is more context specific. If a model is sort of downstream for a particular task, ensuring that the safety objectives and the baseline outlined and articulated in that particular context are being evaluated on. But then again, there are limitations to algorithm audits as well. Given the novelty of this tool, there is a lack of uniform methods, approaches, and metrics, which can sort of impede comparability of the whole auditing process. And this really translates to a lack of standardization and consensus on audit mechanisms, audit criteria, and processes. First and thirdly, for audits to be a truly effective tool, it is very important to understand how independent these interventions really are. So trying to understand who really audits the auditors. And finally, there is a lack of institutional support on auditing as a discipline, though this is now slowly being addressed through legislations like the EU AI Act, to the US's NIST risk management framework, as well as the Digital Services Act in the EU. And why is this all important? Why did we spend time discussing about this? This is to audits and evaluations are really kind of deployed to essentially develop the evidence base to validate the safety of a particular model, which provides insights to guide the extent of its release, access, and deployment. And this is beautifully explained in this lovely graph that I'm a fan of, developed by researchers at Google DeepMind again, where as the evidence base of a model safety grows, so does its access to the external world. And this, of course, is a gradual, iterative, and mostly nonlinear process, requiring model audits to be implemented at different stages of model development, scaling up access to external researchers, to interrogate the model through interventions like adversarial testing, fine-tuning, and also limiting the extent of deployment on the basis of responsible scaling policies that are developed according to the acceptable levels of risk posed by a system. And really centering this conversation that we're having in the practical implications, and really in the context of the open versus closed source debate. Again, there's been a lot of academic, regulatory, as well as sort of journalistic reportage on this particular topic. As you can see here, the calibration of the level of safety and the risk associated with the particular model really guides the extent of its release along this gradient that is developed by this particular gradient developed by Irene Soleiman of Hugging Face. And this gradient varies from fully closed access, where models like Google's imagine which kind of may be associated with significant risks and deep uncertainties, are kept fully closed. To stage release, like stable diffusion stability AI, where the risk profile is a little is kind of a little lesser, followed by hosted access, like DAL-E, like Midjourney, followed by downloadable access, like Meta's OPT and Crayon, to fully open foundation models like Hugging Face's Big Science. And as you can see along this gradient, the higher the level of access, in addition to kind of being able to use the system for more downstream applications, this also allows for higher auditability and community research, which can in turn also increase the safety of an AI system. But at the same time, it can also offer lesser avenues and apertures for risk management and control. So this is a very careful balance, and it's really important that this nuanced understanding of how safety translates to access and gradual access is integrated into public policy and legislation today, in place of really, very honestly, the very binary and reductive nature of the open and versus closed source AI debate. And this really kind of brings us towards the end of our discussion. And looking forward, if there's any takeaway, it's this. Evaluations and audits are inherently iterative. They provide really a level of confidence, with regards to the safety of an AI system, and they really don't ensure that a system is 100% safe or 100%, proofed in terms of ethics. So they have to be. It is an iterative process. It continuously has to be monitored. If there are leakages, if there are discrepancies, they have to be kind of addressed right from the outset. And therefore, they should be dynamically improved to account for advances in model modalities, harms, representativeness. And of course, these are not silver bullets. They are mechanisms that at their very best, again, provide a high level of confidence of a model safety. And what really is important as we kind of progress onto this year, which is really the year of Global AI Regulation 2024, is that consensus and alignment at a global level is bridged on the taxonomy, tools, and criteria for conducting such interventions. And that brings us to the end of our presentation. If there are any questions, I'm happy to take them.
Thank you very much. Are there any questions in the room?
Oh, lovely.
Thank you very much. This is Hasnan Bukhari from University of Erfurt in Germany. Also, thank you for very eloquently putting the very difficult topic. I tried to follow as much as I could. A couple of thoughts, and perhaps you can help me understanding them, because the topic is very complicated. It's not easy, is it? But you do have a great command on it. One thing, you talk about auditability of algorithms, number one. Number two, you also talk about standardization in benchmarking and auditing. And then there was a mentioning of
Adversarial testing or red teaming.
red teaming, yeah? So one question of understanding. Number one, at what level this testing takes place? Like, is it at the level where the algorithms are being written and the companies themselves doing these testing? Number one, that's a question for understanding. Number two, when it comes to auditing the algorithms, do you think in your experience of dealing with this domain, auditing would become possible? Because as of now, this independent auditing seem as quite an ask. I'm not sure if companies, proprietary, would be happy to, happy is a very exaggerated term, to open to this, auditing.
Absolutely.
That's one thing. And the last was the standardization. So what kind of standardization are we looking at? Is it at the governmental level, at these big tech level, or what level would that be, just for my understanding? Thank you.
Absolutely. So 3 questions, all of them are quite fast, but I'll try to kind of answer them as cogently as possible. Coming to your first question, these interventions really depend on, again, I'm going to go to the concentric circle, the thing over here, which really kind of talks about the effects of a model's output across at the model level. So how it manifests on the platform, on the model interface, how humans interact with it, and then followed by how societal structures assimilate this risk over time. And I really kind of rely on this concentric circle to guide who should be conducting such audits. Because right now, a lot of the literature, a lot of the discussion really is at the model level. What are the harms posed by a model, and also the human interaction level? A lot of the evaluations that are conducted and should be conducted are done by the providers of such models. So the tech company. So you've got your OpenAI, Meta for Llama, Anthropic for Claude, et cetera, et cetera. But then you have more contextual evaluations, which are more sensitive to the use case a generative AI chatbot is being used for. For example, if a generative chatbot is being used for like a customer service, use case context, the needs for that are very different from in the FMCG context versus in the medical context. So you will have to have a tailored evaluation that kind of looks and is able to reflect the biases and kind of considerations of both these kind of domains. So it needs to be done initially, at least for the next sort of 3-4 years, by developers, deployers of such models. And once we're fully able to understand the ramifications of these models, how do they impact societal constructs, compositions, etc., it'll be important for kind of governance initiatives from the government, from civil society, from standards making bodies, as well as sort of ombudsman-like kind of functions to really interrogate the implications of the deployment of such models, which can be done through an environmental lens, from a risk-based lens, from a content harm-based lens, and all of that. That's my answer to your first question. Your second question, if I'm not wrong, is around the feasibility of auditability, right? I mean, coming from a company that actually does this, we audit algorithms to kind of generate revenue. We're seeing two kind of aspects of it. The first one is the regulatory compliance aspect of it. Increasingly over the last 2 years, there has been a push towards algorithm audits within regulation, like the EU AI Act, which mentions conformity assessments and audit requirements for all high-risk systems, which can include anything from the recommendation systems deployed by social media platforms to algorithms used in recruitment, to algorithms used in healthcare, to algorithms used in government use. All of them now have to go through an audit. So that's kind of really, emboldening the feasibility kind of component of it. So regulatory compliance, there's something called the New York NYC bias audit law that specifically targets algorithms in the recruitment context. There's the Digital Services Act that mandates independent audits for very large online platforms and search engines as to how their content moderation tools are working, and kind of provide an independent audit of that. So there's a regulatory component aspect of it. Then there's also the market of assurance part of it. And for this, I'll actually use an example I mentioned earlier. A lot of large organizations deploying AI in its kind of different forms and factors are becoming very aware of leveraging the maximum of and kind of maximizing the ROI they get from spending on the AI. And it has just become a thing where if a model is not appropriately stress tested for different things like robustness, efficacy, it can lead to a lot of harms post hoc, post deployment, which can lead to significant reputational harm, economic consequences. And there's this lovely example from Knight Capital, which is a financial services company in the US. They had a faulty algorithm which was used in kind of trading, and there was a glitch in that, and that led to a 440 million loss in one day. So there is an imperative to make sure that algorithms are robust and meet baseline levels of efficacy, which is where we're also seeing a lot of interest when it comes to audits. So efficacy audits and baseline audits, something that we do as well. What was your third question? The standardization aspect of it, right? Wow, I remember all three. Wonderful. So when it comes to standardization, there are actually bodies, non-governmental bodies or quasi-governmental bodies, SDOs, standards development organizations, that are actually made up of a multidisciplinary mix of technologists, ethicists, policy professionals, lawyers, sociologists that actually co-develop these different standards. And there are many of them that are actually doing some very good standards work. For example, I'm a part of the British Standards Institution's ART1, which is ART1, which is the Committee on Artificial Intelligence. For regulations like the EU AI Act, there are bodies like Senelec, ETSI, etc., that are developing standards. In the US, you've got the National Institute of Standards and Technology, NIST, which is developing the risk management framework. And increasingly, a lot of regulations provide principles and leave the implementational details to standards. So this is kind of where standardization really kind of becomes important and something that will increasingly become a very crucial pillar of AI governance in the next couple of years. I hope that answers your question.
Okay, thank you. We are unfortunately kind of running out of time, so that'll be all the questions. But thank you so much for your presentation. And that's the end of the session.
Thank you.